Now the question is, a particle of mass m is released in a vertical plane from the point P at x is equal to x naught on x-axis, right? So what we have is, we have a coordinate axis, this is x-axis, this is y-axis. A particle of mass m has been released from x is equal to x naught. So this is, let's say x is equal to 0, and this is going to be x is equal to x naught. The particle of mass m have been released from this point, right? It falls vertically along y-axis. So it is falling like this, freely. It's a free fall, right, along y-axis, right? So particle is freely falling somewhere here, here, somewhere like this. Find the torque acting on the particle at time t about origin, right? So what has been asked is, the particle is falling freely. After time t, you have to find the torque. So let me find the position after time t. Let's say the particle is here after time t. Since it is falling freely like this, so let's say the particle reaches here. Can I calculate how much distance it has already fallen in time t? Yes, we can. You can simply use S is equal to ut plus half at square. Since it is a state of free fall, right? Initially it was released from here. So initial velocity you can take to be 0. So distance it will travel in time t is going to be half, acceleration going to be g t square, right? So in time t, it will fall the distance half gt square, right? So after time t, the particle will be here. So now you have to find the torque acting on the particle after time t, right? Now before I calculate the torque acting on the particle, I must consider 2 points in mind always. Whenever he says to calculate torque, you have to keep 2 points in mind always. First point is torque of which force. किस फोर्स का आप टॉर्क निकालना चाहते हो, राइट? सेकेंड पॉइंट दैट वी नीड टू कंसिडर इज टॉर्क ऑफ फोर्स अबाउट विच एक्सिस और विच पॉइंट. सो प्लीज कीप दीज टू क्वेश्चन ऑलवेज इन योर माइंड. फर्स्ट, टॉर्क ऑफ विच फोर्स, राइट? यहां पे जब पार्टिकल टी टाइम के बाद पहुंचा है, टॉर्क निकालना है पार्टिकल के ऊपर, तो फर्स्ट क्वेश्चन जो आपको पूछना है, किस फोर्स का टॉर्क निकालना है, राइट? फर्स्ट ऑफ ऑल, ऑब्वियसली द ओनली फोर्स एक्टिंग ऑन द पार्टिकल इज mg, सिंस इट इज इन द स्टेट ऑफ फ्री फॉल, राइट? सो मेरा पहला क्वेश्चन आंसर हो गया, मुझे mg का टॉर्क निकालना है, क्योंकि यही फोर्स है जो इस पार्टिकल के ऊपर लग रहा है उस टाइम पे. अबाउट विच एक्सिस? गिवन, इट्स गिवन दैट you have to find the torque about origin. This is your origin, so I need to find the torque about this point. I hope situation is quite clear to us. इस फोर्स का टॉर्क निकालना है, and about this point I need to find the torque. Now we know how to find torque. Torque is given by r vector cross f vector, right? In magnitude, torque can be written as rf sin theta, right? Rf, what is r cross f? It is rf sin theta. What is theta? Theta is the angle between force vector and your position vector r vector. Now, this formula rf sin theta can be simplified in this way: r into f perpendicular. What is f perpendicular? F perpendicular means perpendicular component of the force, right? It is perpendicular component of the force. किसके perpendicular? Obviously r vector के perpendicular. Perpendicular component of force to r vector. Now torque को आप इस फॉर्म में भी लिख सकते हैं, फोर्स इनटू r perpendicular, right? What is r? r is basically distance, right? Perpendicular distance. किन दो लाइंस के बीच का perpendicular distance? One line is axis of rotation and other line is line of action of force, right? So f into r perpendicular. What is r perpendicular? Distance, perpendicular distance. किसके बीच का perpendicular distance? Axis of rotation and line of action of force. Now depending on the situation to situation, one of these formulas can make your problem very easy to solve. Let's try to solve this question using this approach. So approach number 1, torque can be written as force into r perpendicular, right? First of all, what is force? Force is clearly mg. This is mg into r perpendicular. r perpendicular क्या चीज है? It is a perpendicular distance. किसके बीच का distance? Between axis of rotation and line of action of force, right? This is your axis of rotation. It's quite clear to us. And second is line of action of force. किसको बोल रहे हैं? This is a force, right? इस force के line को आप अगर extend कर दो like this, जिस लाइन के along force act कर रहा है, उस लाइन को अगर extend कर दिया जाए, this is called line of action of force, right? This is called line of action of force, right? So this is line of action of force. इसके बीच और axis of rotation के बीच का perpendicular distance. This is your perpendicular distance, right? This is your perpendicular distance. And we know this distance is equal to x naught, right? This is x equal to 0. This is x is equal to x naught. So distance between 2 points is x naught. So perpendicular distance कितना आ गया हमारा? X naught. So torque can be written as mg into x naught. Okay, let's solve the same problem using approach number 2. That is torque is equal to r into f perpendicular, right? Now again drawing the same diagram. First of all, I need to calculate torque of this force, that is equal to mg, right, about this point of rotation. Using approach number 2, it says torque is equal to r into f perpendicular. First of all, what is r? R is a vector whose tail is at axis of rotation and head is at point of application of force. This is point of application of force. What is point of application of force? It is a point where the force is acting, right? This is point of application of force. Don't confuse this terminology with line of action of. This is called line of action of force that we used in the previous problem. This is called line of action of force. This is a line along with the force x. अगर मान लो force ऐसे act कर रहा होता तो this would have been the line of action of force, right? So what is r vector? It is a vector whose tail is at axis and head is at point of application of force. This is r vector, right? This r vector. This is r vector, right? So using this approach, if I try solving, r को आपको कुछ नहीं करना है, force के आपको components कर लेने हैं, r के perpendicular and r के parallel, right? r को कुछ नहीं करना. This is as such. f का perpendicular component कर लेना आपको. So you need to do the components of force. One will be like this and other will be perpendicular to r, right? So this is one component of the force, this is other component of the force. Let me say this angle is theta. If this angle is theta, this is 90 degree, this is going to be 90 minus theta. Vertically opposite angle 90 minus theta. Complete angle 90 degree hai, so this angle going to be theta. Since this angle is theta, so this can be written as mg cos theta. This component can be written as mg sin theta, right? This is the component of the force which is perpendicular to r vector. So this is the component I am talking about. F perpendicular is component of force perpendicular to r vector. So torque can be written as r को कुछ नहीं करना है, r as such, F perpendicular, right? So this is r as such, F perpendicular कितना है हमारे पास? mg cos theta. Now this is not my answer क्योंकि question में r नहीं given. r तो खुद आपने introduce किया है यहाँ पे, right? So have to bring r in terms of x naught. This length in question was given to be x naught. How to bring it? It's pretty easy. Consider this right angle triangle. This is theta. This is 90 degree. This is base. This is perpendicular, right? This is hypotenuse. Base upon hypotenuse r. This hypotenuse is equal to cos theta. From there you can put r as x naught by cos theta. Substitute it here. What I'm going to get is r की जगह हम डाल देंगे x naught by cos theta into mg cos theta. Cos theta is gone. So torque we are getting to be mg into x naught. It is the same expression that we got earlier. अब difference देखिए, अगर पिछला approach हम लोगों ने use किया, we got answer in one step. Here you need to do 3-4 steps to finally reach your answer. So that's why what I was saying was it depends on situation to situation which approach is going to help you more in a particular situation.